Okay, let's talk GraphQL. So GraphQL is a language. It stands for Graph Query Language. It is used to define contracts between server and client. It's very often used in microservices. It's used in the API gateway to define a proper interface, so you're not sort of depending on the RESTful standard for that, because RESTful standard isn't checked, right? You call maybe with a GET to a service in hopes of getting a particular kind of data, but you may or may not get that data, and that's what we use GraphQL for, as an interface to describe which data we are actually getting and which is actually checked by the server. So since it's an interface, we also need to implement it, but we'll get back to that, and we'll use Apollo Server, which is the most common way of implementing GraphQL. So this is a GraphQL query I call pending games. That's defined, something I have defined in the interface definition, and I'm getting from the pending games, I'm getting two properties. I'm getting ID and I'm getting players. There are more properties in pending games, but I'm not asking for them, which means they're not going to be sent over the network in the request. So we're saving some bandwidth here, and occasionally we will also be saving maybe some database resources, because we can make a simpler request of the database. So that's my request. Now, since this is an interface that we need to define, because I'm showing you the request, not the interface, we will need to have some types. So the types we're using is things like int, float, string, boolean. Essentially things you can have in JSON. And then we have a few special ones, and I want to show the ID. You can look up the list of scalar of types, but the ID is special. You need to think about that as a unique identifier, GUID or UUID, whatever, which means that it's a string. Now, UUID are actually numbers, but they're hexadecimal numbers of such a length that we represent them as a string. So it's not, you don't expect to get something like 7, expect it to be a string. But otherwise these are scalar types. You know how scalar types work. So we can make a GraphQL type. It's still not an interface, but this is the pending game I talked about before. You can see there are in fact 5 different properties, and the ID is indeed an ID. I'll come back to all these exclamation points, but essentially they mean they are mandatory. So the ID is Boolean strings, arrays of strings, and then finally an int. So that's the array I showed you there, right? So I put the square brackets around the type. I think many languages we've seen it in TypeScript. You put string and then square brackets at the end of it, but here we surround it with square brackets. Apart from that, it's an array. There's not much to say about arrays. So this exclamation point then. So it means that it's mandatory, or you can also say it means that it cannot be null. Kind of depends on context, I suppose, but it cannot be null. So here we have, from another example, type credentials, where credentials have a username and a password, and of course you need both. So exclamation point, right? I end up using exclamation points so much that I would have actually prefer the TypeScript solution where you put a question mark when it's not mandatory, but okay. That's what we have. Now, I did show you some arrays, and that array, they had a lot of exclamation points. So let's just see here how we're using that in array. So if you're putting an exclamation point after the array, we're saying this array has to be there. We're not saying anything about the elements. So this array could be null, null, 7, null, 25. If we put the exclamation point instead inside, then we're now saying something about the now we're saying something about the elements of the array. Now they can't be null. Now you know, if you're looking at this array here, we are looking at non-null elements. On the other hand, now the array may not exist. The array could be null instead. So if you want to say, look, this is an array, and what we put in the array is real. We don't put nulls in an array. Might as well not put them there. Then you need two exclamation points. And that's why you're going to see this all over common, sort of common forms of, right, this particular, it's just highlighted, right, this particular point here. Going to see that all over definition, sort of GraphQL definitions. And one thing to note is, just because I'm saying that none of the elements can be null is not the same as saying that there are elements. Empty array still allowed. Empty array still allowed. That's a important thing for you to remember. There is no way, by the way, in GraphQL to guarantee that there is in fact elements in an array. So that's not a part that you can do. So now we can make arrays, we can make types. We can go further and refer to other types that we've made. This is a lot. This is from the actual Yahtzee implementation. That the score is actually an array of arrays, because there are more players, and every player has an array of scores. So now we're getting exclamation point, exclamation point, exclamation point, because none of it is allowed to be null. It's allowed to be empty, none of it is allowed to be null. Another thing is that you can see actually I'm referring to score. I guess you expected to be able to do that. The interesting thing about this is there are specific ways of dealing with that in GraphQL. You may or may not want to deal with that specifically in GraphQL, but if you want to get the full advantage of not having to send everything. But we'll get to that when we look at the Apollo server. So those are the types. You can also make interfaces. Here's an interface. Interfaces, well, they're kind of like you know them, right? If I make an interface game, I am I'm saying, okay, I will want an ID and I will want a pending. And then I have to go and say, okay, let's implement this. So make an ID and make a Boolean. So it's not kind of like, it's not a class, right? You're not getting these for free. You have to write them anyway. So the interface doesn't give you that much, other than saying, okay, but here I want a game that could be either active game or pending game. So that's what the interface is for. So just to make sure, because I don't know, but I make this mistake. So these are mandatory. They're not implied. by interfaces. I guess what I'm saying is it's implements, not extends. Another way to say that, to say, oh, I need a type that could be either active game or pending game, is to make it a union. So you can make unions. I'm using that one in my Yahtzee solution, but that is an alternative. I guess the downside of using a union instead of an interface is if I found that I had a third sort of state for a game to be in, so a third kind of game, I would have to both make the type for that game and change the union, where if I'm using an interface, I can just implement that interface and I don't have to go back and change the interface. It's a small thing, but it kind of gets less cobbled that way. So all of that is defending types, but types are not an interface. Those are just types. So you need to have some kind of methods or services or something. I think we'll see that what we have in GraphQL is more like methods than anything else actually. So let's look at it. So in order to do that, we separate between two kinds of methods. Ones are queries. They return, they don't change anything, they just return values. And the others are mutations. They are supposed to change the underlying data, right? And also return some data. And I think in practice it's going to be relatively difficult to tell them apart. I don't know how you could check that a query doesn't accidentally or by purpose actually change something in the underlying data, but it's not supposed to, and you're not supposed to do that. So the way we do that is we create a type. The type is called query or mutation. So actually both. So and mutation, and they have this special names that are just hard-coded GraphQL. And then to make these things work, because this is our actual interface for our services, then we need to implement resolvers. But that's for the Apollo sections. We just want to say that a query can be either with or without parameters. You saw pending games before, right? That didn't have any parameters. But you can also put parameters if you want, for instance, a specific game by ID. You can use parameters. Mutations. In theory, mutations could be without parameters, but you almost never want that. If you think about what you want in a mutation, you would want data to get to the mutation. So in practice, they will be with parameters always. So the parameters are either primitive types, this is true for queries as well, are either primitive types or a special input type. So you cannot take your normal type, which is what you use for data transfer, right? Or essentially used for data transfer from the server to the client for requests, for the responses, of course. You can't use those in your requests. You would need to make an input type and do that. So I'll show that in 2 slides so you can see how it works. So this is a query. This is a query. You can split this query into several sections and call all of them type query, and it would put them together. It can grow big, but in this particular case, there's not so much, right? You can see here you have the parameterless and the ones with parameters. There's not so much to say other than you can see what they get, you can see what they return, this is your interface, right? You're supposed to write a resolver for games that returns an array of active games. It better return that array, and the array better not have nulls in it, and so on, right? The game by ID returns an active game, but no, that's not mandatory, because who knows if this ID corresponds to anything, right? So that's what you get. You get a null. You could also have more complex parameters. So I'm going into another example because I don't have it in the Yahtzee example, but here is a block system, or part of a block system, where you can create a block. And when you create a block, you want to have some data with it, and I could just use this as 3 parameters. Right? You can just go text string, username string, tag string down in the down here instead. But sometimes it's nicer and easier, especially if you have several of them, right, to just make an input. And do note that this is input, it is not type, and if you try to do it with a type, you are going to get an error. So I'm not sure I understand why that particular thing exists, but it does, and you better do it, or you will have problems later. So that's the input, that's the mutation, that's the query. With all that in place, we have our interface, and we can start coding. So here we see the full GraphQL schema definition, and you can see it's an STL file. We have the types that I showed you: score, active game, and it has a lot of more things, but yeah, but that's the active game, the pending game, and this union, because one of the mutations needs this union, and you can see here I have a query which has these 4 that I already showed you. Then the mutation also has 4 mutations defined, and then we'll have the type subscription, but I'll save that for next session. So let's just start by seeing everything here in one file, from up here to down there.